Today, I am going to discuss oxidation of ketones. Let us see some oxidation reactions of ketones. Oxidation reactions of ketones. First of all, let us take one ketone. Its name is dimethyl ketone. This is also known as propanone. This is also called acetone. This is a kind of symmetrical ketone because here the alkyl groups linked up with carbonyl group are same methyl groups. Based on this point, acetone is a kind of symmetrical ketone. When acetone is oxidized with a strong oxidant like acidic potassium permanganate or acidic potassium dichromate, strong oxidants, because strong oxidants are required to oxidize ketones. Mild oxidants cannot oxidize ketones, so strong oxidants are used. We can use one of the oxidants to oxidize ketones. So here, when acetone undergoes oxidation with a strong oxidant, then either of these carbon-carbon bond will break. This carbon-carbon bond or this carbon-carbon bond. Here, two bonds are same. Suppose this bond gets broken, then this carbon turns into carboxyl group. This portion turns into carbon dioxide and water. Now, let us write products. This carbon turns into carboxyl group and this portion turns into carbon dioxide and water on complete oxidation. So here we learned that when acetone undergoes oxidation with a strong oxidant, then acetic acid is obtained. This is acetic acid. This is also known as ethanoic acid. Now let us see oxidation reaction of another ketone. Another ketone which is unsymmetrical. Ethyl group, here methyl group. Based on this matter, two alkyl groups linked up with carbonyl group are not same, different alkyl groups. Based on this matter, this is a kind of unsymmetrical alkene. Unsymmetrical ketone, not alkene. This is unsymmetrical ketone. Its name is ethyl methyl ketone. Three words. This is also known as 1, 2, 3, 4. Butanone 2. This is also called butan 2-one. These two names are according to IUPAC rule, IUPAC rule. So, when this unsymmetrical ketone is oxidized with a strong oxidant like acidic potassium permanganate, then carbon-carbon this bond or carbon-carbon this bond gets broken to form products. Here, which bond will break? This bond or this bond? According to Popoff's rule, carbonyl group will stay with the smaller alkyl group. So, carbonyl group here will remain with methyl group, then this bond will break. And as a result, the products will be formed. Those are, this carbon will turn into carboxyl group, this carbon will turn into carboxyl group. Here, bond breaking occurs according to Popoff's rule. Now let us write products CH3 COOH, because this carbon turns into carboxyl group on oxidation. The product is this. Plus this carbon as well changes to carboxyl group. Then what will be the product? Let us write CH3 CH3. This carbon will be carboxyl group, so this one. Here we see that when unsymmetrical ketone, ethyl methyl ketone, is oxidized with a strong oxidant, then according to Popoff's rule, we are getting acetic acid. Acetic acid, another acetic acid. We are getting this product according to Popoff's rule. But when this bond breaks, then let us see what compounds will be formed. In this case, this portion will be carbon dioxide and water on complete oxidation, and this carbon will turn into carboxyl group. Then CH3 CH2 COOH. So we are getting here propanoic acid. This is another chance to form products. But here, according to Popoff's rule, these simple compounds are produced. Simple and stable compound is formed, acetic acid. This is the reaction occurs when ethyl methyl ketone, unsymmetrical ketone, is oxidized with a strong oxidant. Not this reaction. This reaction occurs. Another unsymmetrical ketone. This group is isopropyl. This is methyl. Isopropyl methyl ketone, a kind of unsymmetrical ketone. Its another name is 3-methyl butanone 2. Single word. This can be written as in this way: 3-methyl butane 2-one. When this compound is oxidized with a strong oxidant like acidic potassium permanganate, then this carbon-carbon bond or this carbon-carbon bond, which bond will break? According to Popoff's rule, carbonyl group will remain with the smaller alkyl group. So this carbon-carbon bond will break, and as a result, this carbon will change to carbonyl group, and this carbon will convert to carboxyl group. Now let us write products CH3, CO, CH3, that is ketone. Which is known as propanone. Another compound, this one, CH3, COOH. That is, when this unsymmetrical ketone is oxidized by a strong oxidant, then we are getting ketone and acid, propanone and acetic acid. But when instead of this carbon-carbon bond, if this compound undergoes this bond breaking, then we can get these products. First of all, this portion will change to carbon dioxide and water, and this carbon will convert to carboxyl group. Now let us write product CH3, CH, CH3. This carbon changed to carboxyl group. Now, what is its name? 1, 2, 3. 2-methyl propanoic acid. So, this is the compound which is not stable like these compounds, propanone and acetic acid. So, according to Popoff's rule, this reaction occurs, not this reaction. Let us see oxidation of another ketone. Another unsymmetrical ketone. This is tertiary butyl methyl. So its name will be tertiary butyl methyl ketone. 3 words. Its another name will be 3,3-dimethyl butanone 2. This is also called 3,3-dimethyl butane 2-one when this is oxidized with a strong oxidant, acidic potassium permanganate. Then either this bond or this bond will break to form products. But here, this carbon has no hydrogen atom. That is why oxidation of this carbon becomes tough. As a result, carbon-carbon this bond will not break, rather this bond will break to form products. In this case, this carbon changes to carboxyl group. This portion will convert to carbon dioxide and water. Now let us write products. This carbon changes to carboxyl group. Methyl group converts to carbon dioxide and water. What is the name of this product? 1, 2, 3. 2,2-dimethyl propanoic acid. So, when this unsymmetrical ketone, tertiary butyl methyl ketone, is oxidized with a strong oxidant, then we are getting this acid, carbon dioxide and water. Now let us see oxidation of another ketone. Another ketone, phenyl methyl ketone, or we can write methyl phenyl ketone. This is also known as acetophenone. When this is oxidized with a strong oxidant, then either this bond or this bond will break, but this carbon has no hydrogen atom. That is why oxidation of this carbon becomes tough. So this bond will break, this carbon will convert to carboxyl group, this portion will changes to carbon dioxide and water on complete oxidation. Then the products will be benzoic acid, carbon dioxide, water. Benzoic acid. Another ketone, diphenyl ketone or benzophenone. This is also known as the diphenyl ketone. This is single word, this is two words. Diphenyl ketone, when this is oxidized with this oxidant, then these two bonds are same, carbon-carbon bond, carbon-carbon bond. So either of this bond will break to form products. This carbon changes to carboxyl group, this portion changes to carbon dioxide and water on complete oxidation. So the products are benzoic acid, carbon dioxide, water. Benzoic acid, carbon dioxide and water. Let us see oxidation of another ketone. The ketone is this, cyclohexanone. When this is oxidized with acidic potassium permanganate, then this bond or this bond will break. Actually here these two bonds are same, so we can consider just either of this bond will break. Then this carbon will change to carboxyl group. At the same time this carbon will convert to carboxyl group. Now what will be the product? Let us write this carbon, this carbon. So its name is 1, 2, 3, 4, 5, 6. 6 carbon atoms. So it is hexandioic acid. It has a common name which is adipic acid. That is when cyclohexanone is oxidized with strong oxidant, then adipic acid is obtained. Let us see oxidation reaction of another ketone. Now the ketone is this. Its name will be 1, 2, 3, 4, 5, 6. At carbon 2 methyl group. So 2-methyl cyclohexanone. 2-methyl cyclohexanone. When this is oxidized, then this carbon-carbon bond or this carbon-carbon bond, which bond will break? Suppose this bond, then we are getting these products. This carbon will change to carboxyl group. This carbon will change to carboxyl group. Then what will be the product? Let us write. Carboxyl group, this carbon. Here methyl group. The compound will be 1, 2, 3, 4, 5, 6. 2-methyl hexandioic acid. When this carbon-carbon bond breaks, then we are getting this product, 2-methyl hexandioic acid. But if this carbon-carbon bond gets broken, then we will get this product. Here, this carbon becomes carboxyl group and this carbon becomes carbonyl group. Then what will be the product? This carbon, carboxyl group. Here methyl group, this methyl group, this carbon will change to carbonyl group. Now the product will be 1, 2, 3, 4, 5, 6, 7. Carbon atoms are numbered from this carbon because carboxyl group is prior to carbonyl group. That is why carbon atoms are numbered from carboxyl group. Now its name will be 6-oxo-heptanoic acid. Then which reaction is favored? This one or this one? Actually, this is the compound with one carboxyl group which is favored in this reaction. That is why actually this reaction occurs in large quantities. 6-oxo-heptanoic acid. This is all about oxidation of ketones. Thank you very much.